Hi guys, a very good morning. Welcome to the session. So today's session is the third session on Laplace transforms. Yesterday and day before yesterday, I've taken two sessions. First session is on region of convergence. Second session is based on Laplace transforms of some important signals. And this session is based on shifting properties of Laplace transform. Okay. So in this session, we'll talk about time shifting property and S shifting property. Okay. So I'll talk about what I'll be discussing in this session in the next slide. Right. So this is my Telegram group. So if you wish to ask me any doubts based on communication systems or signals and systems, you can contact me in this group. Okay. Right. So what is the agenda of today's session? So I'll quickly discuss yesterday I've given you some homework questions. I'll quickly give you the answers for those questions. And then we'll talk about time shifting property of Laplace transform and how the ROC changes when the time shifting property is applied. Okay. And after that, we'll talk about S shifting property of Laplace transforms. And we'll also talk about how the ROC gets modified because of S shifting property. Okay. And then with the combination of these two or based on each property, we'll do some interesting questions. Okay. After that, I'll give you some homework questions as well. Right. Let us start. So let us quickly complete the homework questions. So del of t minus 2, let's use the property, time shifting property. Del of t minus 2, Laplace transform, if you want to find, first write whatever Laplace transform that you know. So this signal is familiar signal, but we don't remember the Laplace transform of this one. We remember the Laplace transform of del of t, right? Let me change the color. So del of t Laplace transform, if you know, just write it. It is 1. ROC is entire S-plane, right? For all sigma. Now, del of t minus 2, let's apply time shifting property. It is e power minus 2s. Yesterday at the end of the session, I have given you the time shifting property. In today's session, we'll talk more about it. E power minus 2s. Is it for all s? Here, no poles. There are no poles here. What about here? Is there any value of s for which this part becomes infinity? If there is any value of s for which this part becomes infinity, that value of s we call it as pole. See, substitute. If s equal to minus infinity, if you substitute s equal to minus infinity, e power minus 2 into minus infinity is e power infinity, which is infinity. So the Laplace transform is becoming infinity when you substitute s equal to minus infinity. So for s equal to minus infinity, Laplace transform is not defined, not well defined. Okay. So which means Laplace transform, we're going to write those sigma values or those s values only for which the Laplace transform is well defined, which means it should not take infinite values. So ROC, that's why, will not include poles, because at poles, Laplace transform will become infinity, not a defined value. Right. So what is ROC now? ROC should never include poles. So the new pole created because of shifting or because of applying any property, generally the poles might change. Only when the pole distribution changes, only when the number of poles increases or decreases, only then the ROC will change. If the number of poles doesn't change, the ROC also will not change. Here there are no poles, whereas here there is one pole extra created because of time shifting. So because of creation of poles, because of new poles created or because of new poles being removed, because of any property, only then ROC might change. I'm not saying when poles changes, number of poles change, ROC will change. That is also not guaranteed. Sometimes it changes, sometimes it may not change. We'll talk about those examples in this session or in future sessions also. So for now, so since ROC cannot include poles, it should not include minus infinity. So that's why I'm going to write it as sigma greater than minus infinity. Here, sigma equal to minus infinity is also part of ROC. Here, we are removing that sigma equal to minus infinity. Right, next one, u of t minus 2, if you want to find, first find the Laplace transform for u of t. What is the Laplace transform of u of t? It is 1 by s, that we know. ROC also we know it is sigma greater than 0 or real part of s greater than 0. Now, if you apply u of t minus 2, what is the Laplace transform? Using time shifting property, it is e power minus s t naught. The shifting part is minus 2. So it will become e power minus s into 2 divided by s. Using this Laplace transform, I am able to find the Laplace transform of this signal. very easily with the help of time shifting property. What happens to ROC? The ROC is, first analyze. If you want to understand if the ROC changes or not, first analyze the poles. What are the poles here? S equal to 0 is the pole. S equal to 0 is pole. Now what is the pole here? S equal to 0 is pole, correct? Is there any extra pole created because of time shifting? See this function? Because of this extra function created because of shifting, because of this function, is there any pole? Pole means the value of s at which it becomes infinity. Is there any new value? At s equal to 0, it becomes at s equal to 0. At s equal to 0, if you put s equal to 0, this part numerator becomes 1, denominator becomes 0, it becomes infinity. So s equal to 0 is pole, because at s equal to 0, the Laplace transform becomes infinity. So ROC should not be part of ROC. ROC should not include poles, right? That's why sigma is greater than 0, which means this pole is not part of the ROC. Agreed. So is there any value of s because of this function, this extra function? Is there any value of s for which it becomes infinity? Yes. If you put minus infinity, in place of s, the Laplace transform becomes infinity, right? Correct? The Laplace transform becomes infinity, or you might say, sir, it becomes infinity by infinity. So if infinity by infinity means you can apply L's hospital rule, then it will become, finally, after applying L's hospital rule, if you substitute s equal to minus infinity, then the Laplace transform becomes infinity. So at s equal to minus infinity also, the Laplace transform becomes infinity, and hence the Laplace transform is defined only for values of sigma for which it is a finite value. The Laplace transform should take only finite values. Those values of sigma or those values of s for which it becomes finite, that we call it as ROC, right? It has been discussed in the last two classes very clearly, right? Now, sigma greater than 0. In this ROC, is this pole part of it? Is this pole part of this ROC? No, right? Sigma greater than 0 means values from 0 to infinity. It does not include this. So will the ROC change? It should not change, because the ROC, whatever is already there, because of this new pole, the ROC need not change always. It might change or it may not change. In this case, it is not changing because the new pole created is not part of the ROC. If it was part of the ROC, because there is a condition that ROC should not include poles, the ROC will change. Because the new pole created is not part of this ROC, the ROC will not change. So because of time shifting, the ROC might change, ROC may not change also. It depends on the new pole created. The new pole created will decide whether the ROC will change or not. We'll talk about time shifting property again in the next few slides. If there is any slight confusion here, it will get cleared in the next slides. So since this is homework part, I am going little quicker. Right, u of minus t minus 2. First, for you to find the Laplace transform of this one, first write whatever you know. U of t we know. Any signal close to this which you remember, first write that. U of t Laplace transform is 1 by s. ROC is a real part of s greater than 0 or sigma greater than 0. Now from that, you find u of minus t. U of minus t means time reversal property. Time reversal property means when t is replaced with minus t, s is replaced with minus s. If s is replaced with minus s, it becomes 1 by minus s or minus 1 by s. S is replaced with minus s here. Real part of minus s greater than 0, which means it becomes real part of s less than 0. Because s is replaced with minus s, the sign will change if you sign minus onto the other side. Right. Now from this, let's try to get this. Can you write this as u of minus of t plus 2? Is that okay? Minus of t plus 2, if you take minus common, it will become t plus 2. So if you look at it as x of t, then you want x of t plus 2. You want x of t plus 2. Correct? X of t plus 2 means t is replaced with t plus 2. Now Laplace transform of this one, when t is replaced with t plus 2, time shifting property, it is same Laplace transform as it is copied. Because of time shifting, it is e power minus st, e power s t naught, e power s into whatever is the shifting. Shifting is plus 2, c power plus 2s. What is ROC? We have to check now. We have to carefully understand what happens to the ROC. Will it change or not? The pole here is s equal to 0 is the pole. What is the pole here? S equal to 0 is the pole. We already know that. The new pole created, there is a new pole created. What is that? S equal to plus infinity. If you put s equal to plus infinity, then e power infinity becomes infinity. Okay. So Laplace transform becomes infinity when you put s equal to infinity. So it might be, you might see that it is infinity by infinity. So then you can apply else hospital. The total function will become infinity when you put s equal to infinity. So s equal to infinity is a new pole. S equal to infinity is a new pole that is created. But is it part of this ROC? S equal to infinity is not part of this ROC. S equal to minus infinity is part of this ROC. The new pole created is infinity, which is not part of this ROC. The new pole created, if it is not part of this ROC, the ROC will not change. ROC means what? The values of S, the values of sigma or S for which the Laplace transform is well defined. For this value, it is not well defined. Hence, this should not be part of the ROC. Anyway, this is not already part of the ROC. So hence, ROC will not change. If this was part of the ROC, then the ROC might change. Less than 0. So, when time shifting property is applied, the ROC might change sometimes like this. ROC may not change sometimes. You just have to be carefully observant about it. So, we'll take more examples in the next slides. So, you'll understand it better. Hi Rahul. Right, next. Cos 4t into u of minus t. Let's do that. So first, to do that, first write whatever Laplace transform you know that is close to this signal. Cos 80 into u of t. That Laplace transform we have done it yesterday. What is the Laplace transform for cos 80 into u of t? It is s by s square plus a square. ROC is real part of s greater than 0, correct? So the pole here is, there are two poles here, JA minus JA. There are two poles here, JA and minus JA. Okay. Now using this, let's find the Laplace transform of this function which is close to this. Or you want minus t here. So let's replace t with minus t. If you replace t with minus t here, a into minus t. Wherever t is there, we are replacing it with minus t. When t is replaced with minus t, s is replaced with minus s. S is replaced with minus s. Real part of minus s greater than 0. Now it becomes minus s by s square plus a square. ROC becomes a real part of s less than 0 because of this minus sign. So finally, cos 80 into u of minus t. Laplace transform is like this. Okay. The poles also here same, s equal to plus JA minus JA. They are the poles. Now let's understand this one. So this one and this one are same functions. Only thing is, in place of a we are having 4. Let's substitute a with 4. Cos 4t into u of minus t. Laplace transform is minus s by s square plus a square. A square is 4 square, which is 16. ROC is real part of s less than 0. That's it. Let's do the next one. To do this one, let's write a function which we know already. E power minus at into u of t is the function that we remember the Laplace transform. Any Laplace transform that you remember which is close to this, you just write it first. That is the procedure that you should follow. Otherwise, there is a chance of making silly mistakes. C power minus at into u of t Laplace transform is 1 by s plus a. Okay. Now, so what we have here is, we are having t minus 2 here. So first let us find e power minus 2t into u of t Laplace transform, which is 1 divided by, let me take another color so that 1 divided by s plus 2. Pole is minus 2. You can recognize the pole here, minus 2. And you can say, you can confirm the pole here. Okay. Sometimes if you make a mistake, we can compare and understand. The pole we can directly observe here. Whatever is in the power, remove the variable, and whatever is there in the power, that itself is the pole. Is that pole conforming here or not? Pole means, you know, for what value the denominator becomes 0 or the overall value becomes infinite. So what is the ROC here? A real part of s is greater than a real part of minus a. Real part of s greater than real part of the pole. If this was u of minus t, it will be real part of s less than real part of the pole. So it is real part of s greater than real part of minus 2 is just minus 2. Okay. Okay. Right now, let's understand this. We want this. Okay. We want this. Whatever is inside the step function, that is what we have to be taking care of. Okay, we have to take care of that. U of t minus 2. This we can't modify. We can't modify this part. Okay, whatever they have given you, according to that, we have to adjust. The exponential part we can adjust according to the step functions argument. According to the step functions argument, if this is t minus 2, outside you have to adjust according to that. Yeah, Rahul, definitely. So e power minus 2, we are having only e power minus 2t. So that's why let's write it as e power minus t minus 2 into t minus 2 plus 2. Is that okay? I think maybe you are watching it on phone, right? Okay. So this one, let's modify it a little bit. E power minus 2 into t minus 2 plus 2 into u of t minus 2, because they're asking about this function. To get this function, I'm adjusting this function a little bit. See this one? We're doing some adjustments here. Right. So this plus 2 is not required here. Let's put it outside. This plus 2 into minus 2 is plus 4. E power plus 4 outside into e power minus 2 into t minus 2 into u of t minus 2. Okay. See this one? Same thing. I have adjusted a little bit because we want this function. We want this function. So whatever is inside the step function, according to that, we have to adjust the outside function. Okay. Because this we can't modify. We can't write this as t plus 2 minus 2. If you write that, there is no use. Okay. But this one we can adjust. See this one? We have written it as t minus 2 plus 2. This plus 2 we can put it outside and like a constant. That you can't do. You can't play around the same thing with the step. It's inside the step function. Now look at this one. This looks similar to this. Correct? This looks similar to this. Right. So now, okay. Fine. Okay. So what I'll do is, we can adjust like this. You can do it. Instead, there is a better way of doing. Okay. So we want the Laplace transform of this one, right? Whatever we want, let's write it. We want the Laplace transform of this one. So for whatever signal we want the Laplace transform, I'm writing it. So now this we have to adjust. For this one, we want to find the Laplace transform. So once you write whatever signal for which you know Laplace transform, just write that first. Okay, and then write the signal that you want to find the Laplace transform of. Now let's adjust this signal. See this signal, can you apply time shifting property? We can't, because this signal, everywhere t should be replaced with 3 minus 2, then only we can apply time shifting property. So that's not happening here. So let's make that happen. So this signal we are not going to modify. We're going to make some adjustments, same as what I've shown you in the previously, just a minute back. Into u of t minus 2. Now this 2, I'll put it outside, which is e power minus 4, right? T minus 2 plus 2. This plus 2 into minus 2 is minus 4. E power minus 4 outside into e power minus 2 into t minus 2 into u of t minus 2. Now let's find the Laplace transform of this one. This part is looking like time shifted version of this. If this is x of t, this looks like x of t minus 2. Correct? So what is the Laplace transform? Laplace transform of this part is same as Laplace transform of this one, 1 by s plus 2. Because of time shifting, if this is x of t, this is like x of t minus 2. So Laplace transform will be e power minus 2s. E power minus 2s into same Laplace transform. What happens to the ROC? There are no new poles created. Here the only pole is minus 2. Here the poles are minus 2 along with minus infinity. If you put s equal to minus infinity in the numerator, then it becomes, the Laplace transform becomes infinity. So s equal to minus infinity is also a pole. Is that part of the ROC already? No. A real part of s greater than minus 2. It means the values are from minus 2 to plus infinity. Minus 2 to plus infinity does not include this pole. So the ROC will not change. real part of S greater than -2. So this ROC does not include these poles. So right, because of e power -4, we can adjust that e power -4 here. We have found the Laplace transform only this part previously. Now if your constant is multiplied in time domain, same constant is multiplied in Laplace also. Okay, I hope it is clear. You can adjust this. If you want, you can write this as e power -2 into S plus 2. Okay, based on the options, we can adjust the answer accordingly. Is that fine? With that, homework questions are done. But in the homework questions, we have applied time shifting property. Okay, so we'll do some more problems on time shifting property, and I'll generalize things. I'll talk about some points. I'll talk about an important point about time shifting property. What happens to the ROC part? Right. Let me quickly give you the time shifting property again. Let's do some more examples so that we'll get confidence on time shifting property, and then we'll move on to S shifting. Right. X of t, Laplace transform, let's say it is x of s. Okay, ROCS, let's say R. Now, if a signal x of t is shifted in time towards right side by t0 seconds, then what happens to the Laplace transform? Same Laplace transform you can copy. A small change will happen in the Laplace transform, which is e power, an exponential signal is added, e power -s t0 in the power. Along with s, whatever is the shifting part, that will be there. If it is -t0, it will be -t0 here. Is there any change in the ROC? Is there any change in the ROC? It may be there, it may not be there. Mostly, the ROC may not change much. Even if the ROC changes also, it will change very slightly. That infinity minus infinity, only those things, they might become not part of the ROC. Okay, we'll take some examples to understand it better. ROC may or may not change, so that it's difficult to represent it here. So, okay. If it is t plus t0, the Laplace transform is e power s t0 into x of s. See this one? If it is plus sign here, it is a plus sign here. If you ask me a question that, sir, will the time shifting property change the ROC or not change the ROC? Only two options is there. Don't stay in the middle, sir. Sometimes it changes, sometimes it does not change. If you ask me that question, will it change, yes or no? If you ask me that, I would say no, because the ROC is not affected significantly. Even if you observe the previous slide also, see this one? Here, is the ROC affected significantly? Only one pole which is created, that is not part of the ROC. Everything else is same. Because the new poles created because of time shifting S, see this one? What are the new poles that are created here? Because of this one, S equal to -infinity is a pole here, new pole created here. Because of this one, if there is a plus sign here, the new pole created here is plus infinity. The new pole created here is -infinity. So the new poles created because of time shifting property is either plus infinity or -infinity. Only those two poles are possible. Because of time shifting property, there is no other poles that are newly created. Okay. So if the ROC changes, even if the ROC changes also, only that plus infinity or -infinity, if it is part of the ROC, that will not become part of the ROC. Okay, only that plus or -infinity part change will be there in the ROC. Not much change. So if you ask me, if the ROC changes, ROC will not change, you can say. Even if it changes also, very slight, only one point, that is either plus infinity or -infinity, will not be part of the ROC. Only that small change will be there. Okay, right. So let's take some examples and okay, let me write an important point that we have observed here. What are the new poles that are created? New poles are a new pole because only one pole will be created. Because if it is -t0, then it is e power -s t0 here. Because of that, -infinity is the pole that is created. When it is plus t0, plus infinity is the pole that is created. Only one of the poles are created, either plus infinity or -infinity, not both of them. Okay, but if you have linearity property being applied, which means if you are having multiple signals, one shifted towards right side, another shifted towards left side, then there is a possibility of two poles, which is plus infinity and -infinity possible. Okay, new pole created is either plus infinity or minus infinity. Okay, or sometimes if you are having more signals, if you are having more signals, like for example, see this one, e power minus t into u of t minus 2 plus u of t plus 2, something like that. Because of this plus 2, infinity is the pole that is created. Because of this minus 2, this time shifting towards right side, what happens? Minus infinity is the pole that is created. When you have this kind of signals, there is a possibility of plus infinity and minus infinity being created as poles. When there are multiple functions, there is a possibility of both the poles being created, or both. New pole created is either plus infinity or minus infinity or both. Hence, ROC is going to exclude the new pole. Exclude the new pole that is created. New pole created due to time shifting. Observe this one carefully. So new pole created is either plus infinity or minus infinity or both of them. Hence ROC is going to exclude the new pole created due to time shifting. So what I will do is I can write here R minus new pole. Whatever is the new pole, just remove that from the ROC. If ROC does not have this new pole, there is no need to subtract. If ROC is having the new pole, then only we have to subtract. Otherwise, there is no need to subtract. Okay. See here. Here, ROC has this new pole minus infinity, hence we are subtracting. Whereas here, ROC does not have the new pole minus infinity. Here, the new pole is minus infinity. You have to subtract from this. To subtract, you should have it in this, no? To remove the minus infinity part from this, there should be minus infinity part of the ROC. So minus infinity is not part of the ROC, so there is no need of removing. Yes, so I can write in a simplistic manner in this way. ROC, original ROC, because of time shifting, whatever is the new pole created, remove that from the ROC. If it is part of the ROC, remove that from the ROC. If it is not part of the ROC, you can't remove anyway. Okay, I hope it is clear. Is the font okay now, Rahul? So I can write bigger than this also, but the problem is, so say this one, I have started this question, right? So since the questions are here, if I give the solution here, then only it will be easy to understand for you. Otherwise, I have to travel from one slide to another slide every now and then, which might confuse you. So that is the reason I try to fit the solution, which I have to write in that slide itself, okay, by reducing the font size a little bit. Since you are watching in the phone, that's why it might be a problem, but when you are watching on a monitor, it is properly legible. Anyway, so I hope the time shifting property is clear. So I hope you have understood this statement. Read the statement again and try to understand what I've conveyed you here. Okay, right. So see the statement here. ROC of Laplace transform changes only if a new pole, either plus infinity or minus infinity, is created due to time shifting property, is part of the ROC. Whatever new pole is created, if that is part of the ROC, only then the ROC changes. Correct? Aspirant, what happened to you? Always demotivated state. See, not only you, there are lakhs of people who are not clearing mains, right? Not only you. So don't say that always. Don't be so demotivated always. So yes, is not life, right? It is part of our life. Right. So ROC of Laplace transform changes only if a new pole created due to time shifting property is part of the ROC, right? So that is what similar thing I have explained here also. So let me take some examples to explain that further. U of t Laplace transform is 1 by s, ROC is sigma greater than 0, or s real part of s greater than 0. Okay, now u of t minus 2, let me do. Laplace transform is e power minus 2s divided by s. So the new pole created here is s equal to 0 is already, s equal to 0 is the pole, s equal to minus infinity is also a pole. Is the new pole that is created, due to time shifting property, is it part of the ROC? Is it part of this ROC? No, right? So this new pole should not be part of the ROC. That is the only condition. The only condition that we should keep in mind when we are talking about ROC is ROC should not include poles. There is a new pole that is included here. That pole should not be part of the ROC. That is the idea. The only point that is important in ROC is ROC should not include poles. The new pole created should not be part of the ROC. It is already not part of the ROC. Then will the ROC change? The ROC need not change because this pole which is created is not part of the ROC anyway. Right? If it is part of the ROC, then we should change the ROC. That is the point I am conveying here. Let's see one more example. We'll get more clarity. Let's see e of t plus 2. What is the Laplace transform? It is e power plus 2s divided by s. What are the poles? S equal to 0. We know that it is a pole. S equal to plus infinity is the pole. Now, what happens to the ROC? See, this is the original signal for which you have applied the time shifting property. Now, is this pole, new pole, is it part of the ROC? Yes, it is part of the ROC. Infinity is part of this, no? Infinity is part of this. So ROC should not include the poles. So let's change the ROC so that it will not include this new pole. So what will the ROC now? This ROC minus infinity. So how do you write that? Real part of s less than infinity greater than 0. Earlier it was 0 to infinity, infinity included. Now infinity should not be included because it has become a new pole because of time shifting. Right? I hope now you should understand this statement. Because of time shifting, poles are created. If that pole is part of the ROC, we should remove that pole. Here, see this one. This pole is not part of the ROC. Hence, there is no need to remove because it is not already part of ROC. The main point is ROC should not include poles. The new pole created, it should not be part of the ROC. It is not already part of the ROC. There is no need to remove it. So this new pole is part of the ROC. Hence, we are removing and writing it. Okay. I hope it is clear. So I believe you have understood this point. So ROC of Laplace transform changes. When does it change? Only if the new pole that is created, due to time shifting is part of the ROC. This infinity is part of this ROC. Hence the ROC is changing. Here ROC changed because new pole is part of ROC. This new pole is part of this ROC. This new pole is not part of this signal's ROC. For whatever signal you are applying time shifting, that signal's ROC. This is the reference for us. This is the reference signal, reference ROC. Based on this, we are applying time shifting property. So based on this ROC will change or may not change based on the new pole created. If the new pole created is part of this ROC, the ROC will change slightly. Otherwise, there is no need of any change. Okay. Fine then. So I'm moving ahead to the next one. So before moving further, let us do some examples. Okay. Del of t plus 2. I want you to find the Laplace transform of this one. How about this one? I'm taking simple signals. The point is not finding the Laplace transform. That is not the idea here. Finding Laplace transforms many people can do. But understanding what happens to the ROC, that is the critical part in signals and systems. Right. So to find this, what should we do? First write whatever you know. We know Laplace transform of del of t. What is that? It is 1. And ROC is for all values of sigma, correct? For all values of s, for all values of s, or for all values of sigma. Now, when you do del of t plus 2, Laplace transform will be e power plus 2s. There are no poles here. Since ROC should not include poles, since there are no poles, the entire S-plane is the ROC. Here, new pole is created. What is the new pole here that is created? The pole is, there is a new pole here, which is plus infinity is the pole. When a pole is created, when new poles are created or poles are removed, when poles distribution changes, the ROC will definitely change. And what happens to the ROC? ROC should not include poles. That is the only criteria. So since a new pole is created, this should not be part of the ROC. Hence, let's remove the ROC. Let's remove this pole from the ROC. So earlier, what is the meaning of this? It is minus infinity less than or equal to a real part of s less than or equal to plus infinity. This is the ROC for this one. Now, when you're applying time shifting property on this, the ROC may change or may not change based on the pole created. The pole created is part of this ROC. Hence, we have to remove this pole from the ROC and write the new ROC. Let's remove this infinity. We'll write it as less than or minus infinity less than or equal to a real part of s less than infinity. I am removing this infinity here. See this one, equal to is there, equal to is not there here. So I'm removing this pole because this pole should never be part of the ROC. Since pole is infinity here, it should not be part of the ROC of this signal. Right? Now let's do another question. Del of 2 times del of t minus 2 plus 3 times del of t plus 2. Let's do it directly now. Let's apply Laplace transform directly. So first you can write the Laplace transform of the original signal. From that you can find this. Anyway, del of t Laplace transform is written here along with ROC. Now let's find the Laplace transform of this one. Del of t minus 2 Laplace transform is e power minus 2s. A constant is multiplied, same constant will be multiplied in Laplace transform. Next, del of t plus 2 Laplace transform is e power plus 2s. Okay, plus 2s. If whatever constant is multiplied in time domain, same constant is multiplied in Laplace also. If there is addition between two signals, there will be addition between the corresponding Laplace transforms also using linearity property. So this is the Laplace transform. Okay, so this is the Laplace transform. Let us find the ROC part. ROC of only del of t, we know, entire S-plane. Are there any new poles created? The pole created here is minus infinity and the pole created here is plus infinity. The pole created here is plus infinity, the pole created here is minus infinity. Overall, this total signal has poles plus infinity, comma minus infinity. Original signal has entire S-plane as ROC, but the new signal created has 2 new poles extra, plus infinity and minus infinity. Since ROC should not include poles, originally the ROC is entire S-plane. Since the ROC should not include poles, let's remove these poles from this ROC. Let's remove these poles from this ROC. What is ROC now? It will become minus infinity less than sigma or less than real part of s less than infinity. See this one? Equal to signs are there that I am removing here, which means minus infinity is excluded from the ROC. Plus infinity is also excluded from the ROC. Is that okay? So ROC changes when the new poles created are part of the ROC. For whatever signal you are using time shifting property, that signal, that ROC, you take the reference ROC, the new poles created, if they are part of this ROC, remove those poles from the ROC and create the new ROC. Simple. Okay, right. So we have understood time shifting property very clearly. Different cases we have taken. I have not taken tough questions, but I have taken some easy questions, but different cases I have taken to understand how ROC changes. We'll do some difficult questions as well. I mean, The questions involving cos, sine, exponential signals, we can do them as well. But understanding ROC is the crucial part. Right. So let's understand S shifting property of Laplace transforms. S shifting property. So if you know a signal x of t, let's take a signal x of t whose Laplace transform is x of s. ROC is a real part of s, let's write. Now if x of t is multiplied with some signal e power minus at into x of t, then what happens to Laplace transform? S is replaced with s plus a. S is replaced with s plus a. Whenever in time domain, if you multiply with an exponential signal, if you multiply in time domain with an exponential signal, in the other domain, what happens? Shifting is happening. See the previous property? Shifting in time domain, multiplication with exponential signal is happening in the other domain. Correct? So if in one domain shifting happens, in the other domain, multiplication with exponential signal is happening. Or the other way of saying is, if an exponential signal is multiplied in one domain, in the other domain shifting happens. Okay, right. Say this one, exponential signal is multiplied here, so shifting is happening in the Laplace domain. So when shifting happens, it happens overall, even including the ROC also. So when you multiply with e power minus at, s is replaced with s plus a in everywhere, even including the ROC also, it is changed. Okay. Similarly, e power plus at, if you take same thing, instead of minus a, if you take plus a, so replace a with minus a or minus a with plus a. So it becomes s minus a. So s is replaced with s minus a here. S is replaced with s minus a here, because it is multiplied with exponential signal here. So it becomes real part of s minus. ROC also changes according to this. I'll take some examples, then you'll understand. Right. Now understand the difference between S shifting property and time shifting property. I'll put all of them in one place. So let me write it here. X of t, just to, if I put everything in one place, then you'll understand it better. If I take time shifting property, Laplace transform is e power minus st naught into x of s, comma, ROC, what happens to the ROC? Real part of s minus the new poles that are created because of time shifting. Next, how about e power minus at into x of t? So I'm giving S shifting property here. What is that? It is x of s plus a real part of s. S becomes s plus a here. See this? Observe carefully. In an exponential signal, if there is minus sign here, in time shifting property, same sign. In time shifting property, whatever is the sign in the shifting part, the same sign will be there in the exponential part also in the other domain. Whereas in S shifting property, the sign will be exactly opposite. Whatever is the sign in the exponential signal, opposite will be the sign in the shifting part. If it is minus sign here, it will be plus sign here in S shifting property. Whereas in time shifting property, same sign. Okay, right. So if you want, I'll just write the Fourier transform properties as well, so that they are also similar. Okay, if there is any confusion, if you remember Fourier transform property, yes, you can apply that to Laplace transform also, because almost same things. X of t minus t naught. If you want to write Fourier transform property, it is e power minus j omega t naught into x of omega. Similarly, x of t into e power minus j omega naught into t, Fourier transform is x of omega plus omega naught. Same properties, time shifting property of Fourier transform, Okay, instead of S shifting property, frequency shifting property of Fourier transform. Similar thing. See this one? Similar, similar, similar. Right? If at all, if you forget Fourier transform property, if you remember Laplace transform property, from that you can get the Fourier transform property. Or if you remember this, you can get this. It's easier to remember the Laplace transform properties than Fourier transform properties. Okay? Wonderful. So I've written everything in one place so that you'll compare and understand the differences. Once you are done with all the transforms, then what you do is take time shifting property, take the time shifting property of all the transform techniques, Fourier series, Fourier transform, Laplace transform, DTFT, DFT, all transform techniques, write the time shifting property in one place. If you compare them, then you'll not forget them. Similarly, other properties also, differentiation property, other properties also, take one property. If there is a property regarding that concept in every transform, just write that in one place. So that if you once you compare, then you will not forget. There is a chance of forgetting because there are many transforms, same properties in all of them. Some small changes might be there. Okay. So if you observe those small changes, it's easy to remember them. Okay. Right. So S shifting property. So let me give you some examples here. U of t, let's take some basic case. U of t Laplace transform is 1 by S. ROC is real part of S greater than 0. Now if I multiply U of t with e power so minus at into U of t. You know x of t, Laplace transform, we have written that. Now that x of t is multiplied with e power minus at, what happens in the other domain? S is replaced with S plus A. Wherever S is there, replace it with S plus A. Wherever S is there, replace it with S plus A. That's it. We already know the Laplace transform of this one. Did we remember the Laplace transform of this as 1 by S plus A? Yes, that is what we have done in yesterday's session. This is the Laplace transform. We already know this Laplace transform. Just for you to understand the S shifting property, I'm writing it here. From U of t Laplace transform, we're trying to get the Laplace transform of this signal by using S shifting property. When an exponential signal is multiplied in time domain, in the S domain, what happens? S is shifted. S is replaced with S plus A. So the ROC, what happens to the ROC now? A real part of S is greater than this. So if it goes to the other side, it becomes a real part of minus A or minus real part of A. Okay. So this is S shifting property. Now we can do some tricky questions also. Now, having done with the properties and how the ROC changes. Okay, we have to discuss how the ROC changes in S shifting property, right? Yeah. Let's discuss about how the ROC changes. Will the ROC change here? See, here we know the ROC, and here the ROC is entirely different. Okay, so earlier here the ROC is like this, real part of S greater than 0, whereas here ROC is, this is sigma equal to A line. This is the ROC. Has the ROC shifted or not? Has the ROC changed or not? When you are applying S shifting property, is the ROC changing? Definitely it is changing. Okay, ROC definitely changes when you are applying S shifting property. Why? Because the poles are changing. When you are applying S shifting property, the poles are changing. Here, whatever are the poles here, what is happening here? What is happening here? Poles are changing by plus A. Poles are changing by plus A. Earlier, let's say, let me take some example. For example, let's say the poles here are, let's say B, C, D. Now what are the poles here then? S equal to B, C, D are the poles. Just for example's sake, okay? Now, instead of S is replaced with S plus A. The new poles are, what should happen to the new poles? S plus A should become BCD. Now what happens to S? Send this A onto the other side, it becomes minus A plus B is the new pole, minus A plus C is the new pole, minus A plus D is the new pole. Okay, so how much are the poles changing? They are changing by minus A, because if it is S plus A, when you send this plus A onto the other side, it becomes minus A. So poles are changing by minus A. Okay, whereas here poles are changing by, S is replaced with S minus A. So when you send this minus A onto the other side, it becomes plus A. So poles are changing by plus A. So what are the new poles here? S minus A equal to BCD, which is S equal to A plus B, A plus C, A plus D. These are the new poles. If the poles change, will the ROC change? What is deciding the ROC? Poles are deciding the ROC. When the poles change, definitely the ROC will change. Okay. In a shifting property, all the poles are changing. All the poles are changing. Because of S plus A, see, every pole is changing. If the poles change, if the pole distribution change, ROC will change. Zeros have no effect on the ROC. Zeros will not control the ROC. Only the poles will control the ROC. Okay. Wonderful. Right. So let me put those points here. So poles of Laplace transform get shifted when a shifting property is applied. Correct? Poles of Laplace transform, they get shifted. Correct or not? Earlier in the example, see, B, C, D are the poles. Now they are getting shifted by minus A here. Whereas here they are getting shifted by plus A. So poles of Laplace transform will get shifted when a shifting property is applied. So ROC of Laplace transform get shifted when a shifting property is applied. Right. So let me give you some interesting question here. So this kind of question is asked multiple times in previous year papers. If a signal x of t has poles of Laplace transform, poles of its Laplace transform as 4, 5, 8 and 10. Find the poles of, first question, find the poles of x of t multiplied with e power minus 2t. Second question, x of t multiplied with e power 4t. X of t multiplied with e power 3t plus x of t multiplied with e power minus 4t. Let's try this one. Carefully try to do this question. The poles are 4, 5, 8 and 10. There are 4 poles in the signal x of t. Now if you multiply the signal x of t with e power minus 2t, what is its Laplace transform? Just understand the Laplace transform. What is it? It is x of s plus 2. In S shifting property, the sign in time domain and in S domain are opposite. X of s plus 2. S is replaced with s plus 2. So instead of s, we are having s plus 2. Earlier s equal to 4, 5, 8, 10. Now s is replaced with s plus 2. So s plus 2 is equal to 4, 5, 8, 10. Earlier it was s equal to 4, 5, 8, 10. Now s is replaced with s plus 2. Replace s with s plus 2. So the new poles are s equal to, this plus 2 onto the other side becomes minus 2. 4 minus 2, 5 minus 2, 8 minus 2, 10 minus 2. Which is 2, 3, 6 and 8. Correct? Subtract 2 from every pole. Okay. Right. Can anyone tell the answer for the second one? Is there even anyone who can answer me the second question quickly? Come on, come on. Half a minute. That should be more than sufficient to answer the question. So the Laplace transform of this signal is x of s minus 4. The sign is opposite here. So s is replaced with s minus 4. Old poles are 4, 5, 8, 10. The new poles are s minus 4 equal to 4, 5, 8, 10, which means s equal to 4 onto the other side. Add 4 to every term. Anyone? First pole is 8. 4 onto the other side. 4 plus 4 is 8. 5 plus 4 is 9. 8 plus 4 is 12. 10 plus 4 is 14. Okay. 8, 9, 12 and 14 are the new poles. I hope you got the same thing. Okay. How about the last one? This is the tricky question. Among the three, this is the trickiest. So anyone can tell me the poles here? If you can tell the poles of the third signal, then I would say you have become very good in this property. If you can tell the poles quickly of this question, I would appreciate it. First, find the Laplace transform. What is the Laplace transform of this one? X of t into e power 3t. It is x of s minus 3 plus the Laplace transform of this one. X of t Laplace transform is x of s. If you multiply with e power minus 4t, if you multiply with exponential signal, what happens in the other domain? Shifting happens. As shifting happens. It is x of s plus 4. Okay. Now, what are the poles for this one? Poles for this one are different. So for this one, the poles are s minus 3 is equal to 4, 5 and 8, 10. I'm completed. So 3 onto the other side. So 7 is the pole. 3 plus 5 is 8 is the pole. 11 is the pole and 13 are the poles for the first signal. How about the second signal? S equal to 4 minus 4 is 0. 1, 8 minus 4 is 4, 10 minus 4 is 6. There are no common poles here. So the poles of this function, what are the poles for this one? This function has some poles, this function has different poles. If you take LCM, all of them will be the poles of the total function. These two functions together. So what is the meaning of poles here? Poles means in the denominator you are having s minus 7, s minus 8, s minus 11, s minus 13 terms. Here you are having in the denominator s into s minus 1 into s minus 4 into s minus 6. If you combine these two, else in the denominator you'll have s minus 7, s minus 8, s minus 11, s minus 13, s minus 1, s minus 4, s minus 6. So what are the poles? 0, 1, 4, 6, 7, 8, 11 and 13. These are the poles. Okay. Very nice. I hope many of you have got the same answer. Is this an interesting question? Questions like this can be asked. Once the concept is understood, finding answer for these kind of questions is very easy. Okay. Shall we move ahead to the next question? Okay, same question, I'll ask you one more. Same data, with the same data, I'll ask you one more question. Okay. How about find the poles of t minus 4? How about this? Anyone can tell me the poles of this one and poles of this one? Come on, make it fast. Anyone can tell me the poles of this one? You know the poles of x of t, 4, 5, 8, 10. What are the poles of x of t minus 4? To understand the poles, first find the Laplace transform. What is the Laplace transform? E power minus 4s into x of s. We know x of s has poles of 4, 5, 8, 10. because of time shifting, this extra term is created. Because of this extra term, what are the poles? Because of this extra term, any new pole created? Yes, there is a new pole that is created. The new pole that is created is s equal to minus infinity. If you put s equal to minus infinity, this total function becomes infinity. Poles means values of s for which it becomes infinity, right? If you put s equal to minus infinity, then Laplace transform becomes infinity, which means s equal to minus infinity is the new pole that is included. And because of x of s, the old poles are not disturbed. Old poles are same as it is. Then extra pole is created here, which is minus infinity. 4, 5, 8, 10. There are 5 poles in this function. An extra pole is created because of time shifting. Okay, right. How about this one? First find the Laplace transform of this one. It is e power plus 4s into x of s. Okay, so what are the poles for this one? Earlier poles we know 4, 5, 8, 10 are the poles of x of s. Along with that there is an extra function e power 4s. So if there is any confusion, try to understand it. Poles 4, 5, 8, 10 means what is the meaning of it? X of s has in the denominator s minus 4, s minus 5, s minus 8, s minus 10. Right? Along with that e power 4s is there. Because of e power 4s, there is a new pole that is created at plus infinity. Okay. And the old poles are not disturbed because of time shifting property. Because of time shifting property, existing poles will not get disturbed. The new pole of either plus infinity or minus infinity will get created. Whereas when you are applying S shifting property, or when you apply when you multiply with exponential signal in time domain, the poles are completely changed. Every pole changes. Okay. Very nice. Same data. I'll ask you one more question. Sixth one. A into some constant times x of t. What are the poles of this one? What are the poles of this one? Anyone? This is an easy question. Easy question. I want you to answer it confidently. Many of you know the answer, but you are holding back. Have that confidence. If you are very confident, then definitely you'll answer. What are the poles of this one? Anyone? First find the Laplace transform. It is just a times x of s. Because of multiplication with constant in time domain, same constant is multiplied in Laplace also. Because of multiplication with a constant, will the poles change? This constant is multiplied, agreed. I'm talking about the poles. I'm talking about the poles. The question is about poles. We know the poles of a signal x of t. Poles of Laplace transform of signal x of t. I'm asking you the poles of a into x of t. Any change in the poles? So what are the poles of x of a into x of t? Same poles, no? 4, 5, 8 and 10. No change in the poles because of multiplication with constant. Right? Constant multiplications. Multiplication with constant does not affect the poles, or does not affect the ROC. If an operation does not affect the poles, it will not affect the ROC also. Poles are the important part which decides the ROC. Right? One more question. X of t plus e power minus 2t into x of t. Come on, make it fast. Similar question we have done previously also. Similar question we have done here. Come on, make it fast. One more question will wind up today's session. Last two questions. Come on, who will answer me this? It tells you how much focused you are in the session. You can just answer them just like that. How many? 8 poles will be there. Okay, that is fine. What are those poles? Tell me what are those poles. So if you want to tell the poles, just find the Laplace transform first. X of t Laplace transform is x of s plus x of t into e power minus 2t Laplace transform is x of s plus 2. X of s poles, we know x of t poles or x of s poles are 4, 5, 8, 10. So same poles here, s equal to 4, 5, 8 and 10. How about the poles of this one? S is replaced with s plus 2. So s plus 2 should become 4, 5, 8 and 10. What are the values of s? Plus 2 onto the other side, it is 4 minus 2, which is 2. 5 minus 2 is 3. 8 minus 2 is 6. 10 minus 2 is 8. 2, 3, 6, 8. See here, one pole is common here. One pole is common here. So which means you can say repeated pole. It's not repeated pole actually. When you take LCM of these two functions, there will be only one s minus 8. So here, in this function, in the denominator, we are having s minus 4 into s minus 5 into s minus 8 into s minus 2. In this function, in the denominator, we are having s minus 2 into s minus 3, s minus 6 and s minus 8. Okay. So if you take LCM of these two functions, in the denominator, we'll have s minus 4, s minus 5, s minus 8, s minus 10, s minus 2, s minus 3, s minus 6. Because s minus 8 is already in this function. In the overall function, only one s minus 8 will be there. So overall, this total function together, what are the poles? It is 4, 5, 8, 10, 2, 3 and 6. I'm not writing again 8 because it's the same pole. Hi Anil. Okay, so how about the next one? Just simple idea. Is there any way in which we have not discussed any property based on what happens if the signal is multiplied with cos 4t, right? We don't have any such property, but we have S shifting property or multiplication in time domain with exponential signal property. In time domain, if a signal is if x of t is multiplied with exponential signal, we know what happens. See, cos signal can be expressed in terms of exponential signal, right? Correct? See this one? E power cos 4t, can I write it as e power j4t plus e power minus j4t divided by 2. In place of cos, I'm writing this into x of t. Now let us divide this function into two parts. Half into e power j4t into x of t plus half into e power minus j4t into x of t. Now let us find the Laplace transform. It's easy for us to find the Laplace transform of this function. In this format, it's easy for us because we know the property that is involved here. So the Laplace transform of this one is half into x of t. Laplace transform is x of s. If it is multiplied with e power j4t, Laplace transform will become x of s plus j4. Next, how about the Laplace transform of this part? Plus half into x of t Laplace is x of s. When it is multiplied with e power minus j4t, it becomes x of s minus. Come on. Yeah, small mistake here. In S shifting property, the sign will be opposite, right? The sign will be opposite. If it is plus j4, it will be s minus j4. E power minus j4t, the sign will be opposite here. If it is minus sign here, it will be plus sign here, plus j4. That's it. We got the Laplace transform. Let's figure out the poles here. What are the poles of x of s? 4, 5, 8, 10. The new poles are s minus j4 should be equal to 4, 5, 8, 10. And in this function, the new pole should be s plus j4 should be equal to 4, 5, 8, 4, 5, 8, 10. So finally, the new poles of this function are 4 plus j4, 5 plus j4, 8 plus j4, 10 plus j4. These are the poles of this one, this function. How about this function? j4 on the other side becomes minus j4, 4 minus j4, 5 minus j4, 8 minus j4, 10 minus j4. I can write them separately, or else I'll write it like this: 4 plus or minus j4, 5 plus or minus j4, which means 2 poles here, 2 poles here, 8 plus or minus j4, 10 plus or minus j4. So these poles and these poles are conjugate of each other. Okay, so there are 8 poles here. I guess it is clear till this point. You can practice one more. I will give you one question. You can practice it after the session. Same data. Find the poles of sine 60 into e power 4t into x of t. Can you try this one? What happens to the poles of this? We know the poles of Laplace transform of x of t is 4, 5, 8, 10. What are the poles of this new function? This will be taking some time, but same procedure as the previous one. Same question. I've increased the difficulty level slightly. Expand sine function, then things will be very clear. Okay, so can you do it? Can you do this question? You can do this as homework. Okay, sine 60 into e power 14 to x of t. This is also a homework question. So I'll write it in the homework part also. So these are the homework questions. In the fourth question, the homework question is, if poles of Laplace transform of x of t. These are homework questions. So I'm asking you these questions based on shifting properties. Sine 60, right? Yeah. Okay, so take this as homework. So totally 4 questions I'm giving you as homework. If you can answer it, you can post it in the comment section. If you are able to post the answer, if you're able to solve it, if you're confident of the answer, you can post it in the comment section. Okay, so tomorrow first thing I'll discuss the answer for these questions quickly, and then we will move on to the next topic of Laplace transform. We'll be talking about differentiation and integration properties that are involved in Laplace transform. So what happens to the Laplace transform if it is differentiation, and if differentiation happens in time domain, okay, or differentiation happens in Laplace, or integration happens in time, or integration happens in Laplace. So all those 4 cases we'll talk about in tomorrow's session. Okay, so if you have not subscribed to the channel, you can kindly subscribe, and if you have liked the session, if it is useful for you, you can press the like button. Okay, fine. So that's it for today. So if there is any confusion in any part, just go through that part of the class again. Okay, make sure that you become confident of each and every part. So the most important part in bilateral Laplace transform, or the Laplace transform that we learn in signals and systems, is the ROC part. Okay, so make sure you understand the ROC part very clearly. In every class I'll be touching upon ROC, because every property requires understanding of ROC. What happens to the ROC when a certain property is applied? That understanding is the most important part. If we don't talk about ROC, then the Laplace transform that we learn in mathematics, which is unilateral Laplace transform, and the Laplace transform that we learn in signals and systems will not be different. Okay, so without ROC, the Laplace transform in signals and systems learning is useless, right? Very good then. So have a nice day. We'll meet again in tomorrow's session, same time, 8 o'clock. Okay, until then, take care. Bye bye.